California's volcanoes. The state of California contains the third most active or potentially active volcanoes in the United States, totaling 11 volcanoes. These range from the little-known Salton Buttes volcano in Southern California, which is associated with fumaroles and mudpots, to the Long Valley supervolcano, the towering lava domes of the Mono Inyo Field, the glaciers on Mount Shasta, or even the Lassen Peak volcano, which last erupted in 1917. Yet, these are not the only California volcanic features of a fairly recent geologic origin. If you go offshore to the west of the state and into the Pacific Ocean, you will find a series of towering seamounts, with one example being the Davidson Seamount. This seamount is indeed an ancient but now extinct volcano which towers more than 7,200 feet from the ocean floor, covering nearly 180 square miles. Other examples include the Gumdrop, Pioneer, and Guide seamounts, which you might notice all are elongated in a north-northeast orientation. But something is seemingly missing from this cluster of volcanoes. Despite having the profile of large submarine shield volcanoes, they do not contain a summit caldera or series of collapse craters. California seamounts. Yet, there are also a series of similarly aged seamounts which are aligned in a perfectly perpendicular direction towards the east-southeast. The most notable of these are the cluster of 5 Taney seamounts which stretch across a 40-mile-long trend, with the oldest vents being towards the northwest end and the youngest vents being at the southeast end. Altogether, within 200 miles offshore of central and southern California there are at least 25 seamounts which altogether formed in about the same geologic period. These seamounts, which are all extinct, formed almost all collectively between 26 and 10 million years ago, with one seamount, the San Juan Seamount, erupting until 2.8 million years ago. Yet, as we can see by the modern plate boundaries, these volcanoes did not form due to the collision of two tectonic plates, nor did they form due to the spreading apart of two tectonic plates at what is known as a mid-ocean ridge. Rather, these seamounts could all be considered the remnants of intraplate volcanoes, much like how Sunset Crater, which is part of the San Francisco Volcanic Field in Arizona, is an intraplate volcano. In the case of the Central California seamounts, their origin can in fact be traced to the absence of the San Andreas Fault. The San Andreas Fault in California is a strike-slip fault that marks the boundary between San Andreas Fault, the North American Plate to the east, and the Pacific Plate to the west. Yet, this infamous fault line did not always exist, as it only began forming 12 million years ago and had largely expanded to its modern length around 7 million years ago. Note how this period seemingly coincides with when the majority of seamounts ceased their volcanic activity. This is no coincidence. The seamounts which trend in a north-northeast direction represent a section of the crust that once was a mid-ocean ridge. There, the crust spread apart to the east and west, allowing for molten rock and mantle to erupt onto the surface via a series of fissures, forming new oceanic crust. However, this spreading did not always occur in an even manner at different segments, causing what are known as transform faults to form between them, with fracture zones forming parallel with them. Ancient mid-ocean ridge. The transform faults would be the site of eventual east-southeast trending seamounts such as the Taney seamounts. Yet, these seamounts did not form right on top of an active plate boundary, as they instead began erupting around 8 million years after the mid-ocean ridge and transform faults vanished, as they would go on to represent weak points in the crust. These weak points, much like two major fault lines which border the Ewing-Carrot Volcanic Field in Arizona, would go on to provide a path of least resistance for chunks of the upper mantle which just so happened to be slightly warmer than the surrounding regions. This molten rock intruded into the crust before erupting onto the ocean floor, forming chains of volcanoes, some of which had calderas or pit craters, over millions of years. Conclusion. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank Gregory Miller for becoming a new patron on this channel's Patreon page.